Okay, so we've got the name of the river, and we've got the dates. Okay, we've got a little bit of background information. So what we need in there is what part of the syllabus it actually fits with, which is actually freshwater and drainage basins. And maybe a little bit about the Mungnam being a tributary of the Mekong River, which flows into the Mekong. Okay, nice multi-stage map. You can put a scale on those, maybe arrows to locate from there to there, and then where that river is actually located on that map. Okay, fine. Right. So you're using quite a lot of words there, and you might need to reduce those later on. I perhaps put an arrow to the actual the date we actually collected it, March, and then we can refer to the low discharge there. So just leave it there for now, and if you are running out of words, you might need to just reduce that section a bit there. Okay, so aims will need to go just above there. The study was developed for understanding of processes. Now, what we need there is something along the lines of the main aim, which was investigate the downstream changing variables of the Mungnam River, and perhaps give some examples such as cross-sectional area, or hydraulic radius, velocity, discharge, etc. And we need some geographical theory in there. So at that point, I would put the Bradshaw model in, and then show your understanding of the Bradshaw model. Right, on to the hypotheses. Hypothesis 1 is distance from the origin. Distance from site 1, because we maybe didn't go directly up to the source. Distance from site 1 increases, river width will increase in size, whereas the depth will decrease in size. Now, that's not actually technically true. That needs to be changed because width and depth will both increase with distance from site 1. Okay, now the way to approach this is to describe those changes. So closest to the source, the width will be narrow and the depth will be shallow. As with distance from site 1 further downstream, the width will increase and the depth should increase. And then explain why. So link that to tributaries joining the Mungnam River, and then with the tributaries and the additional water, creates more power to erode, so lateral and vertical erosion takes place, such as hydraulic action and abrasion and corrosion, and this widens and deepens the channel. And you can actually word that in a way where it fits exactly to your hypothesis, the way you phrase it. Like I said, that does need changing. Okay, hypothesis 2 is distance from the source increases. Bed load size will decrease, not bed load. Bed load size will decrease. Okay, bed load will decrease in size and roughness. That's fine. But perhaps what you could do there is correlate that with something such as velocity. So maybe with distance from the source, bed load size will decrease and velocity will increase, something like that. I would put velocity in there, and then you can use that data. Okay. So you talked about velocity there, you see, but you haven't got that in your hypothesis. So use the same structure to write that justification as you had suggested for hypothesis 1. You can write about what velocity is like near site 1. You can write about how velocity increases downstream, something along the lines of, while the gradient is steeper upstream, which should increase velocity due to a high bed roughness and a low hydraulic radius, this creates more friction, which reduces the velocity further downstream as more water joins the river. Whilst the gradient flattens out due to a decreased bed roughness and a higher hydraulic radius, velocity will increase. The additional velocity will cause more capacity for erosion in the channel, which will decrease the bed load size by processes such as abrasion, corrosion, and attrition. Okay. I haven't got your methodology, so I need to see the methodology as well.